That's the biggest thing, is if you guys have any questions at all, please don't be afraid to ask those. So, technical difficulties already. There we go. Oh, this is actually a project that I took a picture of in southern Utah. I was lost going to a job, and I had to make a U-turn. But just in case there's any question out there, this is not an approved installation method for PEX, especially for Uponor PEX. There would be no warranty there or anything like that. But this was just something that had caught my eye, that I had seen. It was a little funny. And, you know, being a factory guy, you see the best of the best and the worst of the worst. And this was just one of those things that I'd happened to see. My birthday was a week or so ago, and I've turned 47 now. And I joke with my kids that I'm old, fat, and ugly. Usually my kids say, "Dad, you're not fat." But no. I remember when I first started out, it was kind of that popular term, well, get her done. It didn't matter if it was a piece of 6-inch steel or whatever. I jumped in the trench and just got it taken care of. But now, as I'm older, have a family of my own and kids, safety is important. The number one thing that we need to ensure for everybody is make sure you go home at night. Be safe in what you do. Be smart about what you're going to do. Make sure you do it right. Think about it before you do it and install it. As tradesmen, we deal with a lot of power tools and things to that effect. Please be safe. Make sure you go home tonight, if it's to your race car or to your family or whatever it is. Make sure you're there and you're able to go home. Just a quick question there. Usually I have a lot of interaction, but we'll just keep moving on here. This is a picture of two different stones. One's a cubic zirconium and one is a diamond. What's the difference? What's the chemical difference of the two? Usually somebody speaks up and says, well, the difference is price. One says carat, one says clarity, and on and on. Eventually we'll drill down to it where one is made in the lab and one is made in nature. One is found, I always pictured it, finding it on a beach in South Africa somewhere. But chemically, a diamond and a cubic zirconium are the same. It's carbon. Carbon is the strongest substance known to man. That carbon-to-carbon bond is the strongest bond that we know that's out there. That's why a lot of things are made out of carbon. I'm a car person, so there's carbon fiber hoods, there's carbon fiber fenders. They're even, you know, the new Corvette now has carbon fiber wheels. But it's that carbon strand, that carbon-to-carbon bond that gives us that strength and the lightweight. That's why on our core drill bits, the tips of our core drill bits and some of our hammer drill bits have diamonds baked into those ends, so it'll cut through concrete and steel. It's a very strong substance. So a couple of things here. Everybody's probably installed or seen poly pipe, either in your sprinkler systems or you've seen the yellow gas piping. It's better always known as high density polyethylene, or HDPE. And it has a lot of carbon in it. But when that pipe is made, that carbon is bonded, and in our picture purposes here, it's bonded vertically. So it's only bonded up and down. And a quick example of that is the Solo Cup. And I happen to have a Solo Cup here right in front of me. And I've taken the Solo Cup and I've just smashed it. And if you take that Solo Cup, you can twist it and it tears very, very easily vertical, top to bottom. But if I take that piece and I turn it sideways and you try to tear it that way, if you ever want to be the life of the party, do this. You can't tear it sideways. It still tears very easily vertically, and that's because of the cross-linking from top to bottom. Now let's see if I can get my drawing tool here. It's that cross-linking that goes from top to bottom. And when we tear that cup, it tears right in the middle of that carbon-to-carbon bond. That's what gives the cup its strength. page. There we go. So now we talk about PEX. What is PEX? What does PEX stand for? We hear this a lot. And as a manufacturer, as I go out and after we explain the part of the product, they'll say, well, is Uponor like PEX? PEX is a general term for a lot of things out there. But PEX stands for cross-linked, that's the X, polyethylene. And what is cross-linked in the polyethylene? It's those same carbon atoms that were bonded in that red solo cup. Except in PEX, it's bonded vertically and horizontally. Here in the West, we call it diagonally. As I've been to the South and done some training out there, they call it diagonally. But PEX has that chemical cross-linking all over, so you get that strength not only vertically but horizontally as well. So it basically works like a chain link fence. You have that strength in it. You can't tear it one way or another. The next question is, how many different kinds of PEX are out there? Well, there are 3 different kinds of PEX. PEX A, PEX B, and PEX C. And the reason why they're called A, B, and C is because that's the way that they were invented. We're going to start here with the PEX C at the bottom, right here with CPEX. And what happens is the companies will take the polyethylene resin, they'll put it into a hopper, and they'll extrude it under high temperature like a piece of spaghetti or some pasta. As it comes out of the machine, they will physically X-ray the outside of the tubing to force that carbon-to-carbon bond on the outside. And in this illustration, you can see that you see a lot of that carbon-to-carbon bonding on the outside, but as those rays penetrate the pipe, as you get to this inside of the pipe or the inside of the tubing, you see very little cross-linking happening in there. CPEX has 70 to 75% of the chemical cross-linking in that pipe. B pipe or BPEX, same basic principle. They'll put the polyethylene resin in a hopper, they'll extrude it under high temperature, comes out again like a piece of spaghetti or a piece of pasta. But then they'll take that pipe and they'll cut it into various lengths, say 20-foot straights or 100-foot coils or 300s or 500s or thousands, whatever it is. They'll palletize that, and they will then take that to like a warehouse, and they'll give the pipe a steam bath. And you can imagine as that pipe gets a steam bath, the outside of the pipe will get that silane steam bath, and you'll get a lot of the cross-linking on the outside. You won't get any cross-linking on the inside or the middle of the pipe, and then you'll get some on the very inside of the pipe. Now, if you can imagine, if you have a 100-foot roll or a 500 or a 1,000-foot roll of pipe, and it's in that steam bath, how much of that steam do you actually think gets to the center of that roll of pipe? Probably not so much. So there's actually some cross-linking variances that happen with a C pipe because of the chemical cross-linking. Now, A pipe, PEX A. A pipe is made basically the same way, except it's extruded under high temperature and high pressure. So it's made just like that diamond that's found in nature, that it's all done at the point of manufacture. So if you kind of look at this little drawing here, we have 80% plus cross-linking throughout the whole wall of the pipe, top to bottom, left to right, up and down. When we manufacture half-inch rolls of pipe, or when we make that, we manufacture in 40,000-foot rolls. That roll is technically one molecular structure because of that cross-linking. Now the question is, well, why do we care about APEX, BPEX, or CPEX? Some of the advantages with APEX. Number one is flexibility. When we're installing in the cold or the heat or anything like that, being flexible is really important. It makes it nice. You can take a heat gun and repair kinks. Now, granted, having been in the field myself, you don't get your heat gun and you repair that kink. Chances are you'll just cut it out and put in a coupling. Because of that superior flexibility with the PEX and the cross-linking that's in there, it's designed to use with what is designated as an F1960 fitting. There are others out there that use that designation for fittings now, but that fitting should be used with PEX A, and it meets those ASTM standards. Oops, a little fast there. So this is a piece of pipe that was taken out of a university. It's a 2-inch water main. And you can look at that and say, it's kind of pretty. But what happened is this pipe was placed in what we call hot soil. The dirt was, the pH in this application was actually really high. So it ate the copper in as it sat in the ground. And you can see that as it ate through the wall of the copper, there was a pinhole. The water rushed out of there, and then the water actually destroyed the rest of the pipe. The nice thing about PEX is 100% inert, meaning it doesn't react with a lot of things, a lot of chemicals and hot soils and things like that. There are killers of PEX pipe, and it doesn't matter if it's an A pipe, B pipe, or C pipe. There are certain things that destroy PEX pipe, and we'll talk about that. There's a 4-inch stainless steel line. Stainless steel is not supposed to react with a lot of things as well. But this was on a service call, and you can see the corrosion and the buildup that was in this plumbing system, and it shows up in that elbow. Here's a cast iron fitting that was installed in the same project. It was just a little further down there. With PEX, you do not get that scale buildup. You install a piece of PEX today, it will have the same performance 50 years from now because we do not have that chemical reaction. One of the stories I like to tell, when I first started out as an apprentice, I was working in a large warehouse, and the journeyman that I was working with says, okay, you've learned about enough to be dangerous. I want you to pipe up this bathroom group. And back in when I first started, we were still using copper. And he said, you learned enough to be dangerous, so pipe up this bathroom group. And the bathroom group had a men's and a women's bathroom, so and a drinking fountain. And I worked really hard on this all day. I was sitting there on a cold concrete floor, soldered up my copper, and at the end of the day, the journeyman comes up to me and he says, hey, where's the bird? And I sat there on the floor and I thought for a minute. I said, well, this is a big warehouse. Maybe there's a bird trapped in here. So I really started to look for the bird. Kind of slaps me around a little bit and says, hey, there's no bird in here. It's the bird that crapped all over your fittings. So those of you that's done copper, you can tell probably what my solder connections look like. They look terrible, right? And the journeyman looks at me and says, okay, tomorrow you're going to cut this all out and you're going to do it over. It's going to be plumb, level, and square. My mistake was, well, I said, nobody's ever going to see this again. And he kind of got right in my face and he says, look, at this company, we're craftsmen, and it will be installed right. So my point is with that little story is be craftsmen when you install your piping. PEX can be installed as good as you want or as bad as you want. You can make it look good or you can make it look bad. So with this drawing that I have here, my point is that if you install a piece of pipe and it comes off a fitting, or you're making a radius, or you're bending or something like that, be a craftsman. If it feels like it's going to kink, if it feels like it's on a bind and it's not in good situation, do something about it. Okay, what can be done about it? The number one thing you can do about it is in this picture right here, a bend support. Put in a bend support. Make that radius nice and easy. Saves the fitting. That leads us to the next thing. You could always put an elbow in there. Be a craftsman. Make it look as good as you possibly can. So this is on a project. Being a field guy, also a salesman, we were on a project and we only had won the potable water side of the project. And as I was trying to talk to the contractor, I said, hey, why don't you consider using us for the hydraulic piping as well? And he says, no. I have the best welders in the state. They have the highest quality work, and they're as fast as anybody else can be. As I was walking the project doing a job inspection for him, this welder he was fast and he was quick. And as you can see, just here on the ground is his distribution piping laying there. And he was welding on these outlets left and right. And he was doing a great job and he was going really fast. And I started to think in the back of my head, maybe he's right. Maybe I finally found the contractor that has the fastest and the best welders in the state. Well, as the day went on, and I was walking through the rest of the job, at the end of the day, I started to look a little bit closer at his work. You can kind of see what was happening here. He was tacking on the outlet to the pipe, and then he was just taking the arc welder and his rod, turning up the amperage, and just burning a hole through that pipe. Now we know some engineers like to put a lot of fluff into their systems. I can guarantee you that an engineer did not account for the amount of head loss or pressure drop that this fitting has. Not only, what about the service guys that after this building gets started up and is running, how often are they going to be changing Y strainer screens? How often are they going to be fixing those and cleaning them out? And how many no heats are they going to have for a long period of time? So that's another advantage of PEX, is it will perform the same 50 years from now as it does today. It'll be the same. Some do's and don'ts with PEX. Number one, stay 12 inches away from a standard recessed light fixture. That's just the cheap one that you get from the big box stores and things like that. The question is, why? Why do we stay away from those light fixtures? Number one, it's heat. Heat and plastic pipes don't get along. Depending on what size light bulb, how hot that lamp gets in there, we could have a burst situation that could cause the pipes to blister. So stay 12 inches away from a standard recessed light fixture. Stay 2 inches away from an IC rated can. So IC rated stands for insulation contact. So we need to stay 2 inches away from that IC rated can. 5 feet away from fluorescent lights. Any ideas why? Well, the number one killer to PEX pipe is UV, ultraviolet light. Fluorescent tubes, compact fluorescent lights, and even some LED lights give off a form of ultraviolet radiation. That ultraviolet radiation will destroy the PEX. Doesn't matter whose it is, everybody's PEX has only a certain amount of tolerance to ultraviolet lights. Now, you see in the bottom of the slide here, unless insulated with suitable insulation. So if you have to be closer than that, insulate it with some Armaflex, some split foam insulation, something like that to protect the pipe from those UV rays. Now here's an installation. This was at a university up in Montana. It was a 4-story steel building. When I first got there and got to the job site to do a job walk, this was on the first floor. Now the third floor, they were just finished erecting the third floor, hadn't quite started the fourth floor yet. But I asked the contractor, I said, do you see a problem with this? And he said, no, I don't see an issue with it. Now, in reality, there probably isn't an issue here, but what I want you to be aware of is this. What is this right here? It's a construction light, right? It happens to be a compact fluorescent construction light. And what my question to the contractor was, number one, how long has that light been there? And the second question was, how long is that light going to be there? And we all know on a commercial project, these construction lights never get turned off. So this could be a potential issue depending on how long that light's been there and how long that light is going to be there. Storage for PEX pipe. When you accept delivery or if you get full bundles of pipe, store it inside in its original packaging and keep it away from UV sunlight. Don't throw it on top of your Connex. It's fine if you do that. Don't let it sit there very long. We tell you no longer than 30 days. Keep it out of the sunlight. Indoors, original packaging. If you use coils, we offer a nice coil. It's called punch and pull. Take the center out of the plastic wrapping right here. Take that center out of it and pull the pipe from the center of that coil. Caution, once you do that, and if you don't use the full roll, make sure you don't stick the end back inside the coil of pipe, because one, you'll never find it, and then when you do find it, it usually has a large knot in it. PEX. So Uponor makes multiple different colors of PEX. Our pipe is made all of the same. It doesn't matter if it's 1/2 inch, 3 inch, or 4 inch, if it's red, blue, or purple, the pipe is all identical. Everything that's on the pipe is added in a secondary process. So as the pipe comes out of the machine, doesn't know what it's going to be when it grows up. If it's going to be red pipe for potable, we physically spray paint the outside of the pipe red. We do the same with blue. If it's just plain white pipe, it stays white with just a label on it. Now, if it's a heating pipe, we'll spray an ethyl vinyl alcohol barrier on the outside of it, or known as an oxygen barrier. But chemically, the pipe is all the same. Some things to note with Uponor PEX A pipe. For a continuous domestic hot water recirculation, that means that the hot water recirc pump never shuts off. That temperature for that recirculation needs to be less than 140 degrees. It also needs to be less than 2 feet per second. That's another thing that can damage PEX pipe. Doesn't matter whose it is continuous hot water recirculation can become an issue with that. Okay, plain pipe, 30-day maximum UV exposure. That's just plain white pipe, and that is a cumulative. So if you have 12 hours today, 12 hours tomorrow, and 12 hours the day after, all of that time adds up to 30 days. After 30 days, you can tell there is a warranty issue there, so keep your pipe out of the sunlight. With red and blue pipe, remember, it's painted on the outside. Because of that paint that's on the outside, we give you a 180-day UV rating for that pipe. Another thing that is offered out there is with our energy codes that are changing, getting more stringent now. Pre-insulated PEX is offered in rolls, so you can install a PEX pipe for your hot water lines or your recirc lines that are already pre-insulated and ready to go. It'll save you a little bit of time that way. Uponor always also offers purple pipe for reclaimed pipe, reclaimed water. Here in Utah, that's not a big deal, but in other states such as California and Colorado and Washington, reclaimed water or secondary water is becoming a big plumbing need and issue, so we offer a purple pipe for that. Chemical compatibility. As plumbers, we use a lot of glues and solvents, PVC glues, CPVC glues, ABS glues, tapes, things to that effect. Usually a large ingredient in those adhesives is a chemical called xylene. Xylene and PEX do not get along. Little joke that I use is, have you ever poured salt on a snail? What happens to that snail when you pour salt on it? And it's the same way with PEX and xylene, or a lot of adhesives that are out there. The two don't get along. Stay away from organic chemicals, strong acids and bases. They don't get along very well that way. Petroleum-based or solvent-based paints, greases and sealants, things of that effect, don't get along well with PEX, especially with some of the plastic fittings that are out there. I've seen projects that as they go through a four-way inspection, a certain area won't pass the four-way, and the general contractor will take a can of spray paint and circle a pipe or spray paint the fittings or whatever, what the inspector doesn't. Well, depending on what the problem was, all of that should be removed and replaced if they used a petroleum-based paint. So make sure you use water-based paints. You're going to be marking things. Penetrations. Have you ever been on a project where they've had a 12-inch floor joist that they completely filled with spray foam? What a lot of people don't know is when you get about 6 inches of spray foam, the curing temperature of that spray foam can be over 1,200 degrees. So just imagine that if you had a 150 or 125 pound air test on a piece of PEX and 1,200 degrees, there could be a burst issue there. The things that you need to be aware of is most spray foams are not chemically compatible with plastic fittings. Make sure that those fittings are wrapped with some 6mm tape so that we don't have direct contact with that insulation on those fittings. If it's an Uponor product and you have a question, here's the 800 number. You can call our tech services and they can give you the thumbs up or the thumbs down on that. Okay, how do you make a connection? Just as the picture shows here, first thing you do is you want to make sure you cut the pipe straight, as straight as possible. Take the ring, slide it over the end of the pipe. Now the rings nowadays are different from when I started. There's actually a stop in those rings now, so it only goes on so far. Take the tool, and I'll demonstrate this here in a second, expand the pipe just enough, and then force the fitting into the piece of pipe. So I'll show you that here really quick. Let me turn around. So hopefully I'll hold this up to the camera. Number one, make sure the pipe is cut straight. Take the ring, slide it on the pipe, and it stops. If the ring does not go on, flip the ring over. You have to, it's just on backwards. Take the tool. Here is a Milwaukee tool or some others that are out there, but take the tool, and when you do it, you just squeeze the trigger. Ah, my tool's stuck. You just squeeze the trigger and let it go. So as it expands the pipe, you'll go to the end, you'll expand it one more time and put the fitting in. I'll demonstrate. So one more. Take the ring and the fitting and you slide it in the pipe. Now that is a completed connection. It's fairly warm in my office here today, so that's a connection you could air test here in about 30 seconds and you'd be ready to go. Make sure that the edge of the fitting touches the ring. On T's, there's little nipples that are on the side. Make sure that touches the ring, fully inserted. It's a visual connection. I can walk a project and see if that connection was made properly. Make sure it's inserted all of the way. The other thing you want to do with the tool is make sure that the head rotates. Kind of tough to see here, but the head will rotate around. Now, as it's hotter outside, it doesn't matter as much, but as it gets colder, you want to make sure that that head rotates. If it doesn't rotate, what can happen is you can get these grooves right here on the inside of the pipe. When it's cold, that will delay your air test. Make sure that tool's rotating so you get a nice uniform expansion on the inside of the pipe. This is an example of a project. It was in Fort Collins, Colorado. It was super cold. The contractor called. He had issues with leaks. And you can tell, and what I'd found out, that his tool was broke. And you can see these ridges on the inside of the pipe where the tool did not rotate. Now, again, it's not a deal killer, but as it gets cooler, it becomes more of an issue if the tool does not rotate. So make sure your tool rotates and it's properly taken care of. This is a tool that does only 2-inch. One thing to keep in mind with this tool is that the head does not rotate and you need to physically rotate the tool yourself. This is a larger tool here, and I'm just going to fast forward just a little bit. But these are the tools that Milwaukee makes for Uponor. This little tool here is the one I just demonstrated. We'll do 3/8 to 1 inch. This tool here does 1 inch to 1.5 inches. And this big tool here does 2, 2.5, and 3-inch expansion. It's important with the larger tool that as you're changing heads on that tool, that there's some certain things that happens there. Things that need to happen is these cogs right here on the expansion head need to make sure that they line up with the cogs on the tool. That way you get the proper expansion of the tool. Again, that tool does 2, 2.5, and 3-inch. Must be doing a good job. Nobody's asking questions. Keep moving along. Okay, all PEX is manufactured to a minimum of ASTM. ASTM standard says for PEX, your PEX must be able to withstand 80 psi at 200 degrees Fahrenheit. And this chart here shows you what that standard or interpolated method is for 200 degrees at 80 psi. That is, all PEX must meet this minimum standard. PEX A pipe far exceeds this standard. One thing that we keep in Uponor that is very important to us is minimum cut lengths. We'll get this book out to you if you'll get that information today. But we have minimum cut lengths. So for a piece of 1/2-inch pipe, the shortest you can have two fittings together is 2 inches. Cut that piece of pipe at 2 inches in length, put your rings on, and then expand your fittings and put it together. This is a warranty issue. If your pipe is cut shorter than 2 inches on 1/2-inch pipe, and there's an issue, it's a reason to deny the claim. So very important to make sure you have minimum cut distances for your fittings in your pipe. Now, as you look down on this chart, you can see that the inch has a minimum cut length of pipe of 9 inches. It's important that you keep that. In the commercial buildings that we're in, because of that 9-inch, you may have to be a little creative at times to make sure that you can get everything in there in the space that you have. Very important. Can't emphasize this enough. Minimum cut distance is very important. Tool maintenance. Make sure you take care of your tools. Keep them clean. Keep them lubricated. The head, you saw when I first started there today that the head stuck. That's my demo tool, and I have a problem with pipe dope and grease. If I have it anywhere near me, it just jumps all over my face. But my tool here doesn't have a lot of grease on it, and you notice that it's stuck. Make sure you take care of your tool. When the tool is brand new, you may have to grease it a little more than after you've used it for a little bit. That's one nice thing that's nice about Milwaukee and partnering with Milwaukee is they have a great e-service program. You can email them and then send the tools to them for repair if there is a need for it. In the beginning, we talked about heat sink repairable. You can, because of that carbon-to-carbon cross-linking, if you have a piece of pipe that has been kinked like this, you can take a heat gun. Notice I said heat gun and not a torch. You can heat that pipe up so the pipe goes clear again. What that does is that recross links the carbon atoms that are inside the pipe. Once that pipe cools off and it goes white or opaque again, that pipe will have the same dimensions that it had the day we manufactured it. The other thing about PEX A pipe is we have a higher freeze resistant. We call it the most freeze resistant pipe on the market. It'll expand up to 3 times its outside dimension before we have any issues. I've seen projects that's frozen up before where they've replaced china and they replaced shower valves that they hadn't, but they did not have to replace any of the PEX because it actually would stretch. As the PEX heats back up, it will shrink back down to its original shape. So, like I said, if you are going to repair the pipe, do not use a torch. Please use a heat gun. Reality is, if you kink a piece of pipe, what are you going to do? Chances are you're just going to cut it out and put a coupling in there. So here's a video, and the video is not going to play very well because of my upload speed. I apologize about that. But let me just preface what's going to happen in this video. This gentleman in the video here has taken 3 pieces of 1-inch pipe where he put a plug in the end, and he put this piece of pipe in the burst chamber, and he air tested and filled the pipe up to a pressure that the pipe started to burst. You can see that bubble right here. That pipe started to burst. The test was immediately stopped where the pipe did not physically tear. It just stretched that 3 times. Okay? He does this with 3 samples. He takes a heat gun, he heats up that burst part where it goes clear, lets it cool back down, and he puts it back in the burst chamber, air tests it again, and then takes the pipe to complete failure. Now let's see if we can catch this, and you can see the pressure that happens. Hopefully that's coming through all right. I'll skip forward here in just a second because it's probably really jumpy for you. But you can see how that pipe was clear. This is sample B. We're just going to fast forward through it. There's sample C. He then takes all 3 samples and he marks on the pipe where the burst occurred on all 3 pieces. He then takes a piece of pipe, he puts it inside the burst chamber, and he takes it to complete failure this time. Third sample. So, oops, one too far. So, in that example, or that little video that we showed you there, what did we learn from that video? Number 1, we learned that pipe is the weakest part of the system. And what did that pressure at? Where did that pressure burst at? Between 764 and 800 psi. We test 10 feet out of every 10,000 feet, or excuse me, 10 feet out of every 1,000 feet that we manufacture, and we run it through this test to make sure that they burst at the same pressure. It bursts between 760 and 800 psi every time that we test it. If it doesn't, we fail that pipe and throw it away. The second thing we learned from that video is the strength of the connection system. Face it, guys, when we have leaks in the systems that we installed, it's usually the connection. The thing I say is, okay, was it a Friday connection before payday? Was it a Monday connection after the Super Bowl? Or was it a Wednesday connection at 10 a.m.? When it comes to leaks and connections, usually we as the installers are the weak point. But in an F1960 system and fitting system, the connection part is the strong point. One thing that we recommend here at Uponor is don't be afraid to reuse the brass fittings, but please do not reuse the plastic fittings. If you do want to reuse those fittings, I recommend this tool here. It's a Milwaukee scissor shear. It's about 4 times the cost of everything else, but it's hard to tell in the video. But if you look right here, it's kind of chamfered and dished a little bit. That allows you, just like on this slide here, that allows you to safely score and cut off the ring, where you can heat up pipe and the fitting now to be able to reuse those brass fittings. We strongly recommend that you do not reuse the plastic fittings. Reason being is most people use their razor knife to cut the ring off. Usually what will happen is that knife will go too deep. And you can see in these pictures here, this is a situation where a contractor called that they had multiple leaks on the project. And what had happened is somebody was reusing the plastic fittings. And as they cut the ring and the pipe off the fitting, you can see where it damaged the fitting and it caused a leak. It wouldn't pass the air test. So reality is, guys, we are going to try, right? Everybody's going to try to reuse the plastic fittings. If you do not expose the plastic fitting to high heat temperatures from your heat gun, and make sure you don't cut too deep and cause these score marks in the fitting itself. Let's continue and talk about those fittings. Let's talk about the F1960 fittings. If you take a normal crimp fitting and you compare it to an F1960 fitting, on the right here, you see that dimension C compared to the F1960 dimension C. It comes down to this. The fitting itself is 50% thicker. See if I can get my pen to work. The fitting is 50% thicker, and this is the proof in the pudding right there, with 25% greater flow rate. I've always been a person that says, prove it to me. I don't care if you're an engineer in a cubicle or what. Until I see it in action and working, it didn't make much sense to me. But here's that proof right here. An F1960 fitting will provide 12.4 GPM with 1-inch pipe compared to a standard crimp fitting of 9.9 GPM. The same fitting or the same type of application, the difference is just the fitting type. Oops, too far, there we go. So with Uponor F1960 fittings, that is a standard that we started with and designated is that F1960. We make those fittings in lead-free and brass fittings for hydronic heating applications, as well as EP or engineered polymer or plastic fittings. In this slide here, you can see there's flange adapters, CPVC adapters, and things to that effect. We also have a full line of ball valves from 1/2 inch to 2 inch that meets that F1960 standard. So how tough is a plastic fitting? It's a shame that it's tough on this video that you don't get to see the full video, but I'll just play this, and I know it's going to jump, but we've taken a piece of 2 inch and we put it in the machine and we stretched it and we took it to the limit, and we'll see some figures here at the very end. See if I can stop it just right for you. Ah, that didn't work. Okay. So basically what we did is we took that piece of 2 inch and we stretched it. This is a piece that was in that video. It was 13 inches of elongation. It was nice and straight. Had some of the contractors in Alaska say, huh, we don't need couplings anymore. But it takes 3,000 foot-pounds to stretch it 13 inches. So in this piece of pipe, it's kind of tough to see, but you can tell right here at this edge as we stretched it, it actually started to stretch the pipe. The pipe didn't pull out of the fitting. The fitting didn't break. There are other fittings out there that do not pass this test. One thing I can't emphasize enough, being in the industry myself and having a love for this industry, is please stick with one manufacturer in your system. It just opens up so many other issues. Stick with one manufacturer as you do these things. Having worked for Uponor for 10 years now and had time as a contractor before, I've never seen a fitting or a pipe blow off and cause damage, with one exception. This is a contractor that called me and said, hey, I had a hose bib blow off. It flooded the basement. He says, no big deal, no harm, no foul, but I'd like to find out why. Sent it back to the factory and they had it tested. As you can tell with this paint that we paint on the inside of the pipe, you can see the marks on the inside of the pipe that this fitting was not inserted all the way into the pipe. So this fitting actually did blow off the pipe and flood a basement. Well, we found out later, it was not only was it not inserted all the way, but the fitting had rolled around in his truck for a long time. I called it truck miles. And what had happened is this dimension right here, because it had rolled around in the bottom of his truck, this dimension right here was actually less than our minimum required dimension. So my point is, with the last video on this piece here, make sure you get it inserted all the way. And if you've got some truck miles on your fittings, please don't use those. So here's another quick video. This may not play through very well, so I'm just going to fast forward, maybe. There we go. So we've taken three different samples. On the far left of this video is a complete Uponor system, Uponor fittings, Uponor rings, Uponor pipe. The middle one, I think that information shows up here, an Uponor fitting. It's a PEX B, remember 3 different kinds of pipe with Uponor rings. On the far right, there's a B pipe with Uponor, or not Uponor fittings and non-Uponor rings. And you can see what happens in this stress test that's applied to this fitting. As the fitting continues to stretch, see if we can get to the end here, maybe back up. But the two on the right, the center and the right, actually pull off the fitting. So again, stick with one manufacturer. Here's another quick video. What we've done here is in the top part of this video, as we took, again, a full Uponor setup, a Uponor ring, and an Uponor fitting with a B pipe, and we stretch it. So yes, there is a pipe stretcher. See if it'll back up. You can see how the B pipe pulled off the fittings. You can see how the complete A pipe system continues to stretch and does not pull off. We rerun a second test of this with different manufacturers, different setups in the pipe stretcher, and you can see fairly quickly that both fittings and systems pull apart. My point is, please stick with one manufacturer. Popular trend out there right now is PEX press, where you can take some really nice copper fittings, slide it over the pipe, and smash it, kind of like a crimp ring. I want you to use caution here. Please do not press Uponor brass fittings that are a normal sweat fittings. As you press that fitting and you get that octagon shape, those fittings will crack and leak every time or in every space of that press tool. So do not press Uponor sweat fittings. If you do press, please use Uponor press fittings. We use a higher quality alloy in our sweat fittings, so they're actually kind of brittle and they don't like to be pressed. So if you are going to press, please use a specific press fittings. We have male and female press fittings. Uponor offers a 25-year limited warranty. We're the only PEX manufacturer out there right now that has lived longer than the warranty has been into place. So just some quick installations. If you're doing multifamily installs, and each unit may have a sub-meter in there, we do offer a meter connection fitting, so there's no solder work or there's no pipe dope or threaded adapters. We offer those fittings to go directly to F1960 and water meters. Okay, other connections. Depending on your code, you can connect PEX directly to your water heater or electric water heaters and power vents where the code allows. Make sure you maintain 18 inches away from a solder connection. So if you happen to solder a connection on there or make a transition, make that solder connection first and then put on the ProPEX fitting after that. Make sure you stay away from a single wall vent of 6 inches and 1 inch away from double wall or B vent for those clearances to combustibles. Supporting pipe. Now, if you take just bare PEX, and you run it through a structure, anything 1 inch and smaller must be supported every 32 inches. Depending on code, anything 1.25 inches and larger must be supported every 48 inches. In a stick frame building, TGIs such as this on the right is considered a support, so you don't have to worry about doing anything from there. Okay, when you go vertically with PEX, doesn't matter which size, you need some sort of vertical support every 5 feet, either a tube talon such as this, or there are manufacturers out there that make mid-story guides such as this, 32 inches horizontally. Let's erase that. 32 horizontal, 48 inches and large for 1.25 inches and larger, and 5 feet vertically for all sizes of pipe. Make sure you protect the pipe. Believe it or not, in some jurisdictions that I deal with, nail plates are not required. Cause some issues. When you're going through the top plate or the bottom plate, make sure you use nail plates. When you go through steel studs, make sure you use grommets or Mickey Mouse ears. Isolate it from any sharp edges because PEX moves a fair amount. Bottom line is, make sure you protect that pipe in certain situations. If you're a trunk and branch guy or if you're a multi-port T guy, those multi-port T's, such as this one here or here, they need to be supported within 6 inches of this main connection. So multi-port T's installed within, supported within 6 inches. Quick picture here. I'm just going to throw this out there. Good installation or a bad installation. And that's a good time for you to think about that while I grab a quick drink. So if you look at this picture pretty close, what is this stuff right here? In here. It's leak detector. So you obviously know or realize that there was an issue with this installation and this contractor. You can also tell that in this installation, how this multi-port T is nice and straight with the TGI, and this one kind of bends up on an angle. This was a project that was their very first project. It was super cold, and what they did is they were short. They were short on their 1/2 inch pipe right here. And so they just bent this multi-port T, and because of the temperatures, it leaked right there. So it's important to make sure things are straight and they're not on a bind. Another installation picture. Believe it or not, it's hard to believe, but this does meet the intent of the code. We're supported within about 6 inches of this multi-port T. We're less than 5 feet vertically. It looks terrible, especially with my drawings on there, but believe it or not, it does meet the intent of the code. My journeyman would not be happy with that installation. When you're installing PEX in the slab or below the slab, use coils to minimize the fittings. Uponor has the F1960 approval to bury the connection or the fitting in the slab or the below the slab, and we have the certifications and ratings for that, so you can put fittings in the slab. Most people have issues with that, but we do have those ratings. If you're going to install it in a trench, please make sure that you have a flat, stable bottom. If you backfill it with sand or granular material, and you can kind of tell here, install a snaking pattern. That allows it to expand and contract with time and temperature as it's installed there. As it comes out of the slab, please make sure you protect it, or it comes out of the ground, use some insulation or some PVC sleeves. I've seen power screeds on commercial projects just chop off pipe. So make sure you protect the pipe if it all at all means and needs to be done. If you use brass fittings and you're burying them, make sure you wrap them with 6mm tape. This was a bad day for this contractor digging his trench. Terminations. How do you make those terminations? Well, there are very different ways to make terminations. You can use a copper stub out. You could use PEX for your stub out. There are multiple different ways to do this. All ways are approved by Uponor. My point is, be a craftsman when you do that. When you order your shower valves, it costs no more money to order your shower valves with F1960 fittings. Milwaukee has this unofficial claim to cut the cord. Uponor has an unofficial claim that I call to get rid of the torch. So when you order your rough-in kits, order them with F1960 fittings, and you don't have to have that torch. You don't have to have your shower valves pre-made. A caution in doing that is just make sure you don't use PEX between the shower valve and the tub spout. When you pressure test Uponor, pressurize at 25 psi above working pressure or 100 psi. You know, you can use air, you can use air and water, you can use water. It's up to you. We approve all methods of pressure testing with Uponor. Follow your building inspector, your AHJ, and what they require for pressure testing procedures. Okay, so we've been at this for an hour and 2 minutes. Shall we take 10 minutes and be back at 10:10 to 10:15? Yes? Okay, we'll see you back in 10 minutes, 10:10. Does that work,
Thank
Dave?
you all. We'll keep this going, and we'll let everybody take a time, but we'll keep the video calls up and running. All right, Alan, you about ready to go?
I am ready.
All right, proceed.
All right, so moving on to kind of a commercial aspect. And then don't be afraid to type in any questions, or if you're having audio or video issues, just let us know. So we've kind of gone over do's and don'ts, some residential stuff. Now we're going to kind of move into the commercial stuff. And as far as pipe goes, the pipe's all the same. It's just more of a little bit of installation differences as it comes to that. So when we talk about riser clamps and going vertical now with the system, and it varies depending on what type of system you're installing, if it's domestic hot water or domestic cold water, or if it's a heating hot water issue or heating hot water there. If it's just domestic cold water, take a riser clamp and clamp at the base of every floor and at the top or the ceiling of every fourth floor if you're going that high. Excuse me. And obviously in between those, make sure you have some sort of support every 5 feet vertically. Something that will allow the pipe to move and flex a little bit. Now, if we're talking domestic hot water, make sure you clamp at the base of every floor and the top of every other floor with a mid-story guide or a support every 5 feet. Now, if it's heating hot water or chilled water, make sure you clamp at the base of every floor and the clamp at the top of every floor. So bottom of each floor, the top of every floor. What that does is that allows that expansion and contraction to happen between that riser clamp at the bottom of the floor and the one at the top and the ceiling, and that keeps that expansion and contraction in between those floors rather than across the whole length of that vertical riser. Next is copper tube dimension. On the outside is the same dimension as copper. So when you can use your copper tube talons, insulation, riser clamps. One of the things we want to recommend with a riser clamp is some of the riser clamps are stamped steel, and there can be a sharp edge on the one side of the inside of that riser clamp. Make sure that that's either ground off or you use a different type of clamp that doesn't have that sharp edge on that PEX. We need to protect it as much as possible. So now that was vertical installation. Now as far as a horizontal installation, remember we're 32 or 48 inches when it comes to our horizontal hanger spacing, which is kind of tough with PEX because if you compare that to a metallic pipe, we're about 30% more for those hangers, and labor is some serious money. Uponor offers a product called PEX pipe support that can change a lot of things for us. That PEX pipe support allows us to take our hanger spacings from 32 and 48 to 6 and 8 feet with those hangers, and that's across all sizes, 1/2 inch through 4 inch. So some things with that PEX pipe support for systems that have a delta T less than 40 degrees, and that's ambient temperature compared to operating fluid temperature. You can use PEX pipe support. Your hanger spacings are every 8 feet. Now, a fixed anchor point would be a stiff leg or something like that. If it's less than that 40-degree delta T, there is no fixed point required. Now, if that delta T is greater than 40, say a domestic hot water compared to your ambient temperature, you will need to have fixed points in that installation. That fixed points can be anywhere from 32 to 46 feet. The book that I'm going to send out to you, that will be on page 6. It'll help you decide where those anchor points need to be placed. Here is the chart out of that book. So if it's 0 to 63 feet, you don't need any fixed anchor points. If it's 64 to 128 feet, and keep in mind, this is total straight runs from one end to the other. So if it's perfectly straight, If it's longer than 64 and shorter than 128, you'll need one fixed anchor point, and so on down the line. Now remember, this is for perfectly straight run pipe. If you have an elevation change or you have a direction change, that footage starts over at that point. So if you had a direction change or an elevation change every 63 feet, there would be no needs for a fixed anchor point in your installation. For clevis hangers, systems with a smaller delta T than the 40, you do not have to have the fixed point as well. Again, the building inspector authority having jurisdiction can always hijack that, and we all know that we have to follow what they say. Here's a new product from Uponor. It's called Echo Bumper. No, I'm just joking. This is a product that Uponor makes. We call it EcoFlex. This is not an approved installation method. It does not meet NHTSA requirements, so please do not use it for a bumper. So EcoFlex is a pre-insulated pipe. Has an HDPE jacket, can either have one or two pipes on the inside surrounded by insulation. We go up to 2 pieces of 2.5-inch pipe in one 8-inch jacket. Anything bigger than 2.5-inch pipe, it becomes a single pipe in that jacket. EcoFlex is really nice because it is waterproof. There can be waterproof splices and tees in the ground. It holds its insulation, has a protective jacket on it, and I love it because you can just trench. It doesn't matter if the trench is straight or crooked. After it's done, kick the pipe into the trench and backfill with native material. EcoFlex. A popular trend that is running now with commercial project with PT decks is taking the plumbing from overhead and actually putting the plumbing in the slab. This is a quick picture of a project. This one's in Denver, but you can see they've taken all of the plumbing that they would normally hang with clevis hangers and unistrut clamps and beam clamps and rod and nuts. They take all of it, it's pre-sleeved, and they put it inside the slab to save their labor later down the road. An advantage to this is as contractors, you're able to bill for more of the project at the beginning of it rather than at the end. This is a pre-sleeve project. This is something that we can work with you on with your engineers and your builders to convert and do if you would like. Now, talk about the pressure testing again just a little bit. Reality is we all just take the air chuck with the clip and we hook it on the test gauge and body, and we let the system come up to temperature. Compressor cycles off a few times. Depending on what size of pressure gauge we have, sometimes the needle's buried all the way. Sometimes it stops at 100, maybe goes a little more. We leave it. Maybe we'll flip the gauge a little bit. We'll come back in the morning and it's 7 pounds less than it was when we left it. The question is there a leak? Most of us will say, no, there's not a leak because the temperature changed and the sun went down and the moon moved around and Venus and was in the right position. And no, there's not a leak. And most of the time you're correct. We've developed a testing procedure. In the middle of your book, it's on page 40 and 41. This is a test procedure. I promise you, it takes a long time. It takes 30 to 45 minutes to do. But one promise that I will give you is if you follow this test procedure, if you have leaked, they show up relatively quickly. So basically what we do in that air test is we overpressurize the system. Over a period of 10 minutes, we slowly let the pressure off. We overpressurize the system again. Over a period of 10 minutes, we slowly let the pressure down. We overpressurize it again and then let it sit for 10. We drop the pressure down to just below our test pressure. Over another 10-minute period, we bring it up to test pressure and let it sit. I've seen this happen in buildings where there's been an 80-degree temperature change from the time they put the air test on and when they came back, and the pressure did not drop enough that you couldn't notice it on the test gauge and body. If you want to follow this test, I think it's great. Things will show up quickly if you have issues. Reality is we all know that we'll just put the air gauge on there and call it good. But there is a good test procedure for you. Talking about pipe support. Pipe support is a 23 gauge steel channel. See if I can look through two screens. You can see that. It comes in 9-foot sticks. It's a little more than half round, so it actually clips on to the bottom of the pipe. Now, obviously, this is just a sample with a short piece, but PEX A pipe support gives us some advantages. Like we've already talked about, it changes our hanger spacings to 6 and 8 feet. There are some certain guidelines that we need to follow when using PEX A pipe support. Number one is dimension B here. You can cantilever from your hanger up to 18 inches of pipe support. You can take dimension C when you're taking two different pieces, two different 9-foot sticks, and putting them together in the same run. You must have, like you see right here, a minimum of 6-inch overlap. That's why they come in 9-foot sticks, because you have the 6-inch overlap on each end. That gives you your 8-foot hanger spacing. Dimension D, that is pipe support to fitting. Depending on the size of the pipe, let's say it's 1 inch, that pipe support needs to be within 2 1/4 inches of the end of the fitting or those stops. And the last dimension we talk about is dimension E. When you put it on your clevis hangers or your unistrut clamps, we need a minimum of 1 inch of overhang, maximum of 18, minimum of 1 inch. Pipe support gives us a couple advantages. We already know about the hanger spacing increasing. It also gives us our E84 or plenum rating, to where we can put the PEX in a plenum as well with no edge-to-edge limitations, and it minimizes our expansion and contraction in the systems. So while installing PEX, bare PEX we know has a maximum unsupported length of 32 inches. So in this application, if this piece of pipe was 16 and this piece of pipe was 16, we're just fine. But if that total dimension was bigger than 32 inches, we would have to add in another set of unistrut. There we go. We would have to take that and add more set right here if that total length was more than 32 inches. Now, this is where pipe support becomes really nice. It can become your friend. You have to use a little bit of thought to it, but if you remember, PEX A pipe support can be cantilevered 18 inches. So in this application, you could cantilever your PEX A pipe support out a ways, and that would create this total distance right here to be less than 32 inches, and it would eliminate the additional support needed right there. Now, any questions? Type them in if you do. If they're having any technical difficulties, please let us know. Support branch piping. When you're hanging PEX and installing it, make sure that you support this branch piping right here within 32 inches. Depending on your code, you may be able to go up to 48 inches. The best way to say this is hang it like you would no hub, and you'll be just fine. Ball valves, butterfly valves, things to that effect, make sure you support them. So if you have your butterfly valve, you have a maximum distance here to your next hanger, depending on the size, anywhere from 32 inch to 7 inches. And from this dimension here, A can be your 32 to your 48 inches as well. Make sure you support those larger valves, ball valves, butterfly valves, and things to that effect. Zip ties always come up. Use zip ties to bundle like temperatures in PEX. Zip tie the pipe together for all of your cold. Zip tie your pipe together for your hot. Do not use zip ties to support the pipe and the weight of the content of the pipe. So it shouldn't support it at all. Make sure you keep your temperatures 6 inches apart. Use normal straps, 2-hole pipe clamps, things like that to support the pipe, but do not use zip ties to support the pipe and the contents of the pipe. Fire stop. As we move on here, make sure your fire stop has PEX listed as the through penetrant. We recommend that when you use fire stop, you stick with the big guys here: Hilti, 3, Medical, Passive, Hold Right Pro Set, and STI. We know that those manufacturers are chemically compatible with PEX. So just be careful. Make sure PEX is listed as a through penetrant. Now, the fire stop assembly. We do not tell you how to create that fire stop assembly. Please follow the recommendations of the fire caulk manufacturers on how that assembly should be built for your type of construction. If it's either a wood frame or concrete construction, please follow their recommendations. Okay, this is kind of the hard part that will require some input. Anybody tell me what is wrong with this installation? So see, now you had to pay attention, and now you get to ask questions. Who's the first guy to answer the question? What's wrong with this installation?
Not enough distance between fittings.
Not enough. Whoever that was, thank you very much. You're exactly right. Now, this is 3/4 inch pipe. Here's the next question. Anybody remember what the minimum cut distance was for 3/4 inch pipe? It's in the book I will send you. Minimum cut distance for 3/4 inch pipe is 3 inches. Thank you for your input. What about this installation? Any issues with this install? Believe it or not, this is a good install.
Not coming straight off.
What was that?
Not coming straight off the tees.
Yeah, that's not too bad. That radius there is acceptable. So this installation is just fine because it sits right here in the web TGI, and that is considered a support. You'll be fine. The thing that I'd like to bring up here is look at the install. He has 4 connections here plus a T. Now you can get a 6 connection, cap one end, save the labor on 2, and you're cheaper than buying 2 individual components. So something to look at. How about this install? Any ideas with this? Be careful, it's a trick question. Okay, so our requirement is 6 inches to this multi-port T, correct? The picture is a little far off, but this is actually 6 inches. What's this dimension supposed to be? It's supposed to be 32, right? Believe it or not, this installation meets the intent of the code within 6 inches and 32. It looks terrible, may not be the best install, but it does meet that intent. So believe it or not, it is acceptable. Okay, there's a handful of things here. Somebody typed in the answer or the answer to the questions. What is wrong with this install? Anything?
There's
First,
not enough distance, and then the spray foam.
right. Okay. In this installation, the spray foam may not be an issue. As long as it is an icing-based spray foam, this isn't an issue. But it's a good talking point, because if this was a lot and it was touching the fittings, that would be an issue. Okay. One other thing, maybe tough to see on your picture, but there's one other issue here. What's happening right here? It's duct tape. Remember that some adhesives can have xylene in them. So being a good plumber, if you ran this pipe and was going to cap it off to keep the dust and the wood shavings out of there, it's easier to cut off the pipe than try to remove the duct tape. There could be some long-term issues. Believe it or not, Gorilla Glue duct tape does not have xylene in it, and we approve it to have direct contact with our pipe. It works great. Good luck getting it off, so you're going to end up cutting it off anyway. So, same installation. I just took the picture further back. Two issues here. Somebody give them to me. The brave ones. Lots of questions coming. So, number one right here. Missing a nail plate, correct? My journeyman would get upset because one, it's not plumb level and square. My point is, if you're going to make this bent or bowed, why not drill the hole further up here, take one piece of pipe and loop it all the way down and save 3 fittings. Work, there's nothing wrong with it, but the installation could have been done at a higher level of efficiency. Install here, not my product, but it doesn't matter. What's wrong with this installation? Somebody's got to give this one to me.
Solvents on the pipe, glue, yeah.
Exactly. How do we fix it? The only way to fix this is to cut the pipe out and replace it. Here's an install next to a can light. Too close, right? We need 12 inches away from the can light because it's a cheap can light, or 2 inches away from an IC rated can light. In this installation, how do we fix it? The only way to fix it is to rerun the pipe.
Tell the electrician to move his line.
Yeah, right, exactly. Take it down and smash it, and make him move it. Now, usually the interior desecrator wins, and as plumbers, we have to move, right? What about this install? Good, bad, ugly, acceptable? I think this is a fabulous install. This contractor, it's actually a commercial building. This contractor was very conscientious of how he installed the product and made it look good. I harass him every time and I tell him that this pipe right here is in the wrong spot. It should have been over here. No, but reality is this contractor really cared about what he did and how he installed it. And you can make your PEX systems look as good as you want or as bad as you want. Now, any issues with this install? You can see he's got zip ties, bundling his like temperatures. So one thing I like to point out in this system, look at the mains. The mains come from way off here to the right. They turn and they go into the multi-port tees. Then his hot line comes out of the multi-port tees and goes right down towards the mains, right? Well, my point with this is let's do some quick math. If they were to take these multi-port tees and get the ones that are half the size, so rather than 12 ports, there'd be a 6-port. Take a 6-port and put it right over here. Take the other 6-port and put it down here somewhere. That's a terrible arrow. Okay. What that does is that allows them to not use all of this 1/2-inch pipe. So on this project, it was a 650 unit multifamily project. And I went to the first unit. I said, if you move these multi-port tees to here and here, you're able to save 100 feet of pipe per unit. That was 6,500 feet of pipe for the total project. Now that's some serious money somewhere. Just by thinking about the project a little bit different, you can save some installation time, you can save some material, and be a little more profitable on the project. So, not really anything wrong with this install. It's busy. He used a lot of extra material. God bless him, because it was my material. But if you think about it different, you can be more efficient in your install. Another install. It's okay. It's acceptable. But look at this. He has 3 holes drilled here. He's got 3 more holes drilled here. 3 here. 3 here.
I don't think I muted anymore.
You what?
So there's a lot of holes there.
Muted anymore.
So my point is, with this installation here, take it, put your like temperatures together, and rather than drilling all of these holes, drill bigger holes. So you put all of the pipe through one hole rather than it's through its own individual hole. So 3, 6, 9, 12, 15, 18 holes you can get by with 2, 4, 6, 8, 10, 12 holes. So something to think about. Uh-oh. Technical difficulties. I hate it when that happens. Stand by, I'll get it back, I promise. Of course, it might be an excuse to leave early, right? Okay, we back? Somebody give me the yes or no? Uh-oh.
Yes.
Okay, we're good. Okay, so here's another, this is a commercial install. If you look at this one, you can tell where you use the PEX pipe support. Cantilevered it down 18 inches. He's got his support here for other parts of the piping. It's a fairly good install. Now here's a picture I'm kind of ashamed to show, but I show it anyway. This is a contractor. And if you look at it, what is he doing right here? He has his razor knife and he's cutting off the rings and the pipe to plastic fittings. Now, if you recall, I suggested that you do not reuse plastic fittings. This was a fairly large commercial project and they constantly had leaks. If you use the F1960 system with the appropriate tools, I've seen commercial installs, 8, 10 floors go without any leaks under air test. If you have more than 1 or 2, let's look at it. But in this application, that was this gentleman's full-time job. That's all he did every day was to reclaim plastic fittings. My question is, how many of those fittings did he damage trying to reuse them? If you have this many leaks on a project, please give me a call. Get in contact with me. I'll send you my info. There's a training issue. I failed this contractor. I did not train them properly. You can do full projects without any issues. Now here's a project. This is a good installation, but just to show you, it takes about 3 minutes to do this 2-inch connection right here. And on this install, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then over here, 13 and 14. There's 14 2-inch connections that can take up to 3 minutes of connection. If you think about this install just a little bit different, you can save a bunch of time. This is a men's and a woman's bathroom group. On the back side is the men's room. On the front side here, closest to you, is the women's. If you think about it a little bit different, take this 2-inch line down and at about 6 or 8 feet, run it high. We make those multi-port tees that are 2-inch here, 2-inch here, and then there's 3 1-inch connections off from it. Those 1-inch connections can now go to your flush valves, and it saves a bunch of 2-inch connections. So think about your installation just a little bit different, and you can save time in that aspect. Here's another install. I think this is a fantastic install by the way they utilize the PEX pipe support, and they have their 6 and 8 foot hanger spacings. Fantastic install. Another good install, maybe a little overkill on the clamps, but this gentleman cared about the way he installed his project and the way he wanted it to work. Again, a good installation. However, if you think about it just a little bit different, you can save some time. Look at the water mains. This is the main that comes all the way across. It comes down. Excuse me. In the water delivery system, the half pipe goes the directions of the water mains and then goes to the fixtures. My point is, if you think about this just a little bit different, you could take these multi-port tees that are here and place them right here and save 10 feet of pipe times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 100 feet of pipe used in this installation that could have been saved, could have been made the project a little more profitable, could have got you out of that room quicker and onto the next room. This is a shower valve that was ordered with F1960 fittings. No soldering was required, and they looped the pipe right off from the shower valve. Now be careful, because honestly, most of the time there's a 2x4 right here, and you may have to put an elbow in it anyway. But try to loop it before you use fittings. Another install with PEX pipe support. This is not an approved method to use PEX pipe support underneath your fittings. If you're going to create what we call a fitting bridge, that piece of PEX pipe support needs to be 1 to 2 sizes larger, so you have that continuous pipe support underneath that PEX. Now remember, by having that continuous pipe support, you get the E84 or the plenum rating on the project system, or the pipes do not have to be insulated per E84, but energy code may dictate otherwise. Installation in a commercial project, I think he did a fantastic job here. You notice that as he goes through the studs, he has his Mickey Mouse ears or his grommets as he goes through there to protect the pipe. I don't think he could have done a better job with this because it was steel framed. Now, what's wrong with this installation? Somebody give me an answer.
Different types of PEX.
Okay. Believe it or not, the PEX is all the same. What I want to bring out in this installation is, look, there's this manufacturer with the pipe and fittings. There's this manufacturer of a crimp ring. There's this manufacturer of a different tee. Now, will it work? Yes. It scares me a little bit. But my question is if this leaks right here and causes damage to the structure or the building, who pays the warranty claim? And that's an easy answer. It's the contractor. It's the plumber, because no manufacturer will stand behind that, simply because there's more than one manufacturer involved with the connection. Now with this install, it's an okay install, but my point is, if you're going to do this, why don't you just loop it with PEX A and you eliminate the fittings, the crimp rings, the potential issues with that installation. What's wrong with this? Now I set you up on this. PEX should be stored in its original packaging indoors. Now, this one here was just a delivery that was just made, so it's all right. But it just shows the point that it needs to be installed or needs to be stored indoors out of UV light. Last question or last picture that I see that I like to bring up. This is lazy plumbing, gentlemen, and I hope we're all craftsmen here. If you look here in the bottom, that's a 1/2 inch T, and he just ran the 1/2 inch on the floor. Ruin things for the tile guy, for the cabinet guy, everything. Don't be a lazy plumber. Be a craftsman. Oops, that's not the right setting. We want to remove that. Go here. Erase. Okay. Here's the fun part. Test questions. Now, make sure all your information is in to Dave, and I'll get you a certificate, etc. Number 1, when making a ProPEX connection, place the ProPEX ring on the pipe to the stop edge. B, make sure the expansion head is installed and rotating properly. C, do not force the pipe onto the expansion head when expanding. Or D, completely insert the fitting so the pipe and the ring reach the fitting shoulder. What do you think? All the above. 2, maintain a minimum distance between ProPEX fittings to prevent damage to the fitting, to prevent damage to the expansion head, or all the above. It is all the above. 3, when storing PEX pipe, keep it in original packaging, out of UV light. Or C, all the above. It's all the above. 4, when making ProPEX copper transitions, maintain a minimum of 18 inches between solder and sweat and ProPEX connections. Make solder sweat connections prior to the ProPEX connections. Use ProPEX lead-free copper press adapters for a flameless transition, or all the above. It is all the above. 5, Uponor's full 25-year warranty requires using Uponor PEX pipe with Uponor PEX fittings. That is true. Per IPC and UPC, support bare pipe every 32 inches, every 48 inches for 1.25 inches and larger, or every 5 feet vertically. It's all the above. 7, when installing the PEX systems, make sure to maintain a minimum distance of 12 inches from recessed light fixtures, 5 feet from fluorescent lights. Do not use PEX between the tub shower valve and the tub spout, and that is all the above. When installing PEX, below grade, use EP fittings that are approved for direct burial. Cover the brass fittings with 6mm tape. Sleeve all concrete and masonry penetrations. True, all the above. 9, when pressure testing Uponor PEX systems, make sure to A, pressurize to 25 psi above working pressure or 100 psi. Use a mixture of water and air. Use air when allowed by code, or all the above. It is all the above. 10, we're almost done. PEX pipe must be protected when passing through steel framing. True. What are the horizontal support requirements when using PEX A pipe support? Maximum distance is 8 feet. Support the fittings 1.5 inches and smaller within 12 inches. Clamp the pipe at a maximum of 32 feet. All the above. It is all the above. 12. When installing PEX pipe support, minimize cutting by using full lengths when possible. Deburr sharp edges. Strap according to figures 35 and 38 in the book I will send you, or all the above. It's all the above. See a pattern here? To minimize expansion and contraction in the systems with delta T's greater than 40, support PEX with pipe support. Clamp the pipe at a maximum of 32 feet. Use fixed anchor points or all the above. You guessed it, all the above. 14. When installing PEX piping for vertical riser applications, support at the base of each floor. Support every 5 feet. Clamp at the top of the floors according to the system. Hot water or cold water or heating water, is it different, or all the above? It is all the above. And last but not least, 15. When pressure testing large volume commercial PEX systems, fill a system with potable water, air, or a combination of both. Condition the pipe to 1.5 times the test pressure or 120 psi for 30 minutes. After 30 minutes, release the excess pressure until you reach the desired test pressure. Monitor the system for leaks over the required time period, or E, all the above. Congratulations, you have all passed. Now, if you have questions, please type them in. If you have questions you just want to ask, go ahead and ask them. Otherwise, thank you for your time. I'm right on time for you for 2 hours there. Ask away. Otherwise, we'll disconnect here shortly. Dave?
Thank you very much, Alan. Excellent training. We appreciate it very much. Are there any questions? All right. Just make sure, everyone, that you send me your physical address. That way I make sure I have the correct address so that we can send your certificates from Uponor and the book and any of the other items that Alan has that he's going to share with you. The Doppel credit will be uploaded in the next couple of days. If you have any questions, you're more than welcome to give me a call. Alan, did you leave them your email address or anything?
I have not, but I will put that in here. Here's my email. Well, that's my phone number. And so there is, Stu answered that other question. Going through foundations and penetrating through that wall, we suggest 100% silicone, but Stu is right. Get us the MSDS sheet and we can tell you yes or no. Any other questions?
Well, thank you, Alan. You did a wonderful job.
Thank you, Dave. Thanks for attending, guys, and there's my info, and we'll go from there. Have a good day.